Welcome to Applied Geography. Today we're tackling convection currents. So let me just give you a quick overview of the diagram. So here we have the core. I've used red dots because it's experiencing radioactive decay, which is releasing huge amounts of energy. And it's the hottest part of Earth's layers. Okay. Next, underneath this, or above the core, we have the mantle. We need to break it down into the lower mantle and the upper mantle. Okay, and we really need to know that the temperatures are different in these subsections of the mantle. On top of the mantle, we have the crust, which we know is broken up into tectonic plates. Okay, and that's why this is relevant, because this is one of the real big causes of the movement of tectonic plates, so essentially earthquakes and volcanoes. So, why do kids often struggle here? Why are you maybe here? I think you need to understand this idea of density, okay? Warm things are less dense. That's why they often rise up. Warm air rises, right? Think about a hot air balloon. Cold things tend to be more dense. Okay, and so they sink. You know, cold air sinks. And that's what you really need to know, is that we have this thing called density, and warm things are more dense and cold things are less dense. That really is central to this whole process or cycle. Okay? Right. If you got your head around that, we can kind of start to approach this. So just remember, we have the core, we have radioactive decay, huge exothermic reaction taking place, and that is emitting huge amounts of energy into our mantle. Okay, and it's creating our semi-molten layer. So what happens is, due to the radioactive decay in the core, the magma in the lower mantle becomes less dense. Okay, and so it begins to rise. It rises like so. However, this is our heat source. So if you can make any connections to atmospheric cells, then that's brilliant, because as it rises, it's getting further from the heat source and it starts to cool down. Okay? And we know cool things, they start to sink. Okay? As they sink, they get heated up. And this happens in a cycle. You know, we call this a conventional cell. So again, atmospheric cell, convection cell. Okay? So the same thing is happening here as well. That magma is rising. As it rises, its temperature starts to decrease. And so it starts to sink, becomes more dense. And as it sinks, it gets heated up, and this happens in a cycle. This becomes a kind of continuous flow, and so it's happening in a cycle. It's going around and around and around, and that's kind of pretty much all there is to it. Now we need to look at the causes of it, now the effects of it. Well, what are the effects? So what happens is, rising magma can kind of push the tectonic plates away. So as it kind of rises, it pushes them away. Because even though this is cooling down, it's still rising. Okay? And then at the same time, falling magma or sinking magma can pull the plates. Yep. And so what we see is they are both pushed and pulled by this convection current. And this gives our tectonic plates movement, okay? So we have our tectonic plates moving in different directions. Just clear that up. And so we see here is going to be a divergent plate boundary. And we can form a mid-Atlantic ridge, or potentially a shield volcano, like so. But again, that's not really what we're here for. We're here for the convection currents, okay? So, anything else? This is the big cause of tectonic plate boundaries and their movements. And so just a quick recap, we have, in the core we have radioactive decay. This causes our magma in the lower mantle to be heated up, to become less dense and to rise. As it rises, it begins to cool, becoming more dense, causing it to sink. This happens in a continuous flow or a cycle. And that really is it. Okay, I'll flash the words. I'm sure I'll flash the words up to what they are. We're going to jump into an exam question now on how I could turn this process into a full marks answer. All right, guys, today we're going to look at a 3-mark question from the Geography B Excel paper in 2020. So let's have a look at what it contains. So, explain one cause of tectonic plate movement. Bug the question, pause it if you know how to do that. It's a relatively clean and simple question. Okay, so what I'm going to do now is I'm going to bug it for you. So, box the command word, explain. Obviously, one is important. Cause tectonic plate movement. So it's a pretty simple question, right? There's not many words that we need to cut out there. And then we glance at the marks and we see it's 3 marks. So, we're going to get a mark for the point and 2 marks for the development. So here is our mark scheme. Again, you might want to pause it and have a little look. What we see here, convection currents, radioactive decay, push, pull, drags, okay? Lots of this is kind of variations on the same kind of answer. So here is our structure. This is how I would teach my kids how to get those 3 marks. So 1 blank is, that's going to be cause. In goes our point. Because is our first kind of connective. And as a result being our next one. So in some ways, or in reality, you're getting 3 marks for 2 sentences. So let's see how I did that myself with a modelled example. So one reason is convection currents. There's my point, and there is my 1 mark. Okay, I say in the mantle, probably would still get a mark if I just said convection currents. Because this current of magma are generated by heat from radioactive decay in Earth's core. So as an examiner, as soon as I see radioactive decay, I'm awarding my 2nd mark. So yeah, I'm at 2 now. And then I put, this means that in, could be as a result, this means that, but either it's fine because I'm doing that 2nd development. This means that tectonic plates are pushed, pulled, and dragged over time. So really, I'm linking it back to the question in some ways. I'm just saying, look, they're moving, they're being pushed and pulled over time. Again, the 2nd mark. I think that's actually quite wordy. You could probably get all 3 marks doing less. But again, it's very simple if you combine your point with 2 connectives and you use that core geographical language like radioactive decay, like drag, push, pull, earth core, mantle. You're going to pick up those 3 marks very, very quickly. I believe that gets 100%. I hope you found this useful. Tune in next time for more videos like this.